In this section, we're going to learn about layouts in .NET MAUI. Layouts allow you to organize and group user interface controls on a page. Choosing a layout will require you to know how each of the controls are positioned and sized within a specific layout. That is why in this section, we're going to analyze each one of them. In this image, we see each of the layouts and we see what I have mentioned about how the controls are positioned within each of the layouts. We can see a design that shows some simulated controls for each of these layouts, and it is this positioning that we see within each of these images that will differentiate each of the different layouts that we are going to see next. Let's start by examining the first layout called StackLayout. This type of layout organizes elements in a one-dimensional stack either horizontally or vertically, and is typically used to organize a subsection of the graphical user interface on a page. Let's take a look at this layout in a new project. To do this, let's proceed to create a new project. Let's select the .NET MAUI template and we will name the project StackLayout Demo. Once the project has been created, we will proceed to create a new page as part of this project. Let's right-click on Add New Element. From the .NET MAUI category, select a content page in XAML format and name it StackLayout Demo. Once we have created this new content page, we're going to indicate that we want to start the application with this page. For it, we have to go to app.xaml.cs and we're going to replace this page with StackLayout Demo, which is the new page that we have created. And this is how the application looks like with the new page that we have created. If we go back to the Explorer and we see this page that we have created, we can see that it has been created as part of this content page, an element type StackLayout, which is precisely the first type of layout that we're going to talk about. This type of layout, as I mentioned before, stacks the different elements that are located within this layout. Let's copy this label element, for example, and let's paste the element once again. With the changes applied, we can see that we have a second element that has been stacked as I mentioned before. Let's proceed to change the background color of each of these labels elements. For example, let's apply a color Alice Blue to our first label. And we're going to change to our second label the property background color for a color, for example, dark blue. We can see how each one of these labels elements that have been stacked, as I have mentioned, as part of this stack layout looks like. To do some tests, let's proceed to copy once again the label element. Let's paste it 3 more times. Let's change the background color to dark red. Let's change the other background color to dark cyan, for example. And to the last element we assign a color, for example, brown. Okay, here we have each of these elements that have been stacked as part of the stack layout. We also have the option to change the orientation of the different elements that are part of the stack layout. By default, the elements are being stacked vertically, but we could also stack them horizontally. We're going to assign for it a property that is part of the stack layout that is called orientation. Let's change the property to horizontal and we see how the elements have been stacked in a horizontal format. In this way, we can then change the orientation of the different elements. Let's remove this property to leave the elements in a vertical format. And as part of the different elements in the XAML file, we have a property called vertical options. And we have also a property called horizontal options, which will allow us to modify how the different elements are going to be positioned with respect to the layout or the page in which we are. For example, we can modify the vertical options property of this stack layout, which will allow us to specify where this stack layout is going to be located specifically. We can indicate that, for example, we want to place the stack layout right in the center. And look how simply we have indicated that we want the stack layout located vertically right in the center. By default, each of these elements has no spacing. If we would like to assign some spacing between each of the elements as part of the stack layout, we also have a property called spacing, which we can modify to alter this spacing between the different elements. In the preview, we see precisely this spacing that we have indicated between each of these elements. Now, as part also of each of the elements of the stack layout, we can assign where each of these labels controls will be placed individually. How can we do it? Well, using the same property, but in each one of the controls. For example, if we wanted to modify where this first element is going to be located, we see that we're using the vertical options property and the horizontal options property to specify where we want to place this element or this control as part of the stack layout. We can indicate that we want to place this label element in a different location. Here we have different options that we can select. For example, let's indicate that we want to place the element at the beginning of the stack layout. And with this, what has happened is that precisely this element label has gone to the beginning of the stack layout. We have some additional values, as for example, this value center that we have already seen what it is used for, to position the elements in the center. We could also place the elements at the end of the stack layout, and with this, the element would be pushed to the right. We also have a set of values that end with the term and expand. And that term refers to the fact that we are going to place one of the elements, for example, in the center. And this word or this term that says and expand means that we're going to try to occupy the available space, if there is any, so that all that space is filled. For example, we could indicate that we want to fill all the space and expand it with this label element. If we look at the preview, we see how this element has indeed been pushed to fill all the space that was available as part of the stack layout, although the text only uses some of this space we have available. If we were to do the same for its vertical options, we will indicate fill and expand. And with this value, look how the label is occupying all the space that is available, all that space that is not using the other elements, because we are indicating that we want to fill precisely all that space with this label element, although the text content is only using a small portion, but the entire control as such is using all the space. And this is how we can work with this layout element called StackLayout. As part of .NET MAUI, we also have a couple of layouts that are derived from StackLayout. They are called HorizontalStackLayout and VerticalStackLayout. I have created a new project with the name HorizontalVerticalStackLayout Demo, and I have created a couple of pages. The first one called HorizontalStackLayout Demo, and the second one called VerticalStackLayout Demo. Let's proceed to see precisely this type of layouts. This type of layout, as I mentioned before, are derived from the StackLayout. This means that we can use these stack layouts in case we know that the orientation of the elements is going to be horizontal or vertical. The advantage of using these layouts is that they have a better performance than a stack layout, since each of these layouts is specifically optimized to work with horizontal or vertical elements. First, let's examine horizontal stack layout. We will proceed to copy this element a few more times. Let's place this page as the home page to see how those changes we have applied look. Let's start the application. Here we see the results of this execution, and we see precisely that each of the label elements are being arranged in a horizontal format. Let's proceed to look at the second page, which is this page called VerticalStackLayout Demo. And let's change the stack layout element to the VerticalStackLayout element. We're going to proceed once again to copy this label element, and we're going to paste it a few times, and we're going to change the initial page to VerticalStackLayout Demo. We start once again the execution of the application, and we see that this time the elements are being stacked in a vertical format. As I said before, if you know that you're going to use only one type of alignment, for example horizontal for the elements, I recommend you to use horizontal stack layout instead of the normal stack layout, and if you know that the elements are going to be in a vertical format, in the same way use vertical stack layout so that you have a better performance as part of your application. Let's examine the next type of layout called grid. This type of layout is a type of layout that organizes the different controls in rows and columns, which can have proportional or absolute sizes. By default, this layout type contains one row and one column, and can also be used as a parent layout containing other child layouts. Let's demonstrate this type of layout. I have already created a project called Grid Demo, and inside the project I have created a page called Grid Demo Page. As we always have this content page with its respective stack layout, we're going to proceed to remove the stack layout since we are interested in testing this new type of layout called grid. Inside the grid element, which is the layout that we are testing, we can add some button type elements through this tag that we are seeing. We're going to place a text, for example, click me, and we're going to close this tag. You can do it this way, or you can also define a second button. We're going to place a text equals .NET MAUI, and you can also close the label this way, placing a backslash followed by the greater than symbol. We're going to indicate that we want this page as the initial page, and let's start the application to see what this change looks like. Here we can see the initial behavior of this type of layout. We see that the button is using all the available space, that is, it uses all the space of the page type content page. We can see the text that we specified for this button, and perhaps you may be wondering where the second button that is part of this graphical user interface has been, since we do not see it. The second button that, if we go back to the code, was specified with the text click me. Well, the default behavior is that this layout tries to occupy all the available space, in this case on the page, and positions the different elements one on top of the other, since we are not specifying that we want to place the elements in another way. Remember that by default a grid creates a column and a row, and that is why we have a single space for all the content we are viewing. Fortunately, we have a couple of properties that will allow us to create more rows and more columns in this layout grid. How can we do it? Well, we simply have to place ourselves just below the grid tag, and we have to access a property of the grid called row definition to define a set of additional rows. Or we also have the property called column definition to indicate that we want an additional set of columns. We will proceed to work first with the property called row definition, and if we want to create new rows, we have to do it through the label called row definition. We can do it again in this way that we are seeing here, or we can indicate row definition and immediately close the label. In this way, we are creating a couple of rows as part of the application. With this simple change that we've made, let's visualize what has happened. We see that as part of the application, the pair of elements that are actually a pair of buttons have been positioned right in the middle of the mobile device at the top. And this, remember, is because we have indicated that we want two rows as part of the layout. Once again, the elements are positioned on top of each other, since we are not indicating that we want to position, for example, one of the buttons at the bottom. But before learning how to position the elements, let's proceed to test the second property that we had seen previously, which is the column definition property. Let's indicate that we want to define a set of additional columns. I'm going to do it this way. I'm creating a couple of columns. I'm going to save the changes. Let's visualize the results. And this is what the application currently looks like, since we've indicated that we wanted a couple of columns as part of the application. This is the first column and this is the second column. The next step is to learn how to position the different elements in each of the sections that we have defined. Well, to do this, we have to imagine that this is a set of different positions or coordinates. Assume that this first position is position 0 for the columns and 0 for the rows. The second element is for column number 1 in row number 0, since the indexing starts from numbering 0. So this would be the first row, this would be the second row, this would be the first column, and this would be the second column. So if we wanted, for example, to position an element in column number 1 and row number 1, we would have to modify our code to indicate that one of these elements has been positioned precisely in that location. Suppose we want to place the second button, the one with the .NET MAUI text. That we would have to do this is to access a property called grid dot, and here we can specify in which row we want to position this element. We're going to indicate that we want to place this element in row number 1, and we can also access the column property to specify that we want to position this control in column number 1. Let's visualize the changes, and this is how the application looks See how this time the elements have been positioned in different locations as we have specified in the SAML code. Now, maybe you could ask yourself the question, how could we place an element so that it occupies more than one column or more than one row? For example, if we wanted to place this second button so that it occupies the whole row. Well, to perform this action, what we would have to do is to access a property that is also part of the layout, which we can access through grid, dot, and we have this pair of properties called column span and row span, which allow us to specify how many spaces we want to occupy a control. So, for example, if we wanted to use 2 of the columns, we would have to indicate column span equal to 2, and with this change, it seems that nothing has happened, and it is that here we must consider that we have started the numbering from column number 1. Remember that as part of the SAML code, we indicated that we wanted to position the element in column number 1, but here the correct thing would be to indicate that we want to position the element in the initial column from which we're going to start taking each of the columns. So let's indicate that we want to start in column 0 and that we want to take 2 columns. With this change that we have applied, look how the button is already using all the available space, which in this case are 2 columns to place this element, specifically this button. Another thing we can do as part of this type of layout is to specify a size for the rows and columns. And we can do this in both the row definitions and the column definitions. For the case of the rows, we can specify a height value, and for the case of the columns, we can specify a property called width. As part of the values for each of these properties, we have 3 ways to set the values. First, we can specify a fixed value, as in this case we are seeing on the screen. If we update the changes, look how the button at the top has been greatly reduced because we have indicated that we want the first row to have 10 units only for the different elements that we position as part of the row. If we change the values, for example, to a value of 50, look how the size is modified because we have changed the size of the row definition. A second value that we could set is the value called auto, which basically that it will do is to use all the space they need, the internal controls to take only that space. In this specific case, if we look at the preview, we see that the button is using only the space it needs for the default size of the button. If we go back as SAML code and proceed to change, for example, the size of the button through the property called height_request, we will indicate that, for example, we want to use 200 units for this button. If we return to the preview, look how the space that is using this row is larger because, as I indicated earlier, we have specified that the height of this row will be equal to auto. It will take the space needed to fit each of the controls that are part of this row definition. Finally, we can use an additional value that is the start value. And basically, when we use this value, what we are indicating is that we want to use all the available space. If we visualize the changes, notice what is happening visually. Although this control is using only 200 units, which were the ones we specified in the SAML code, the size of this row is exactly 50% of all the available space. That is, using this start value is the same as if we had not assigned any value as part of the SAML code, since it is distributing the space between this pair of rows. The space will be distributed among the number of rows or columns that we define. But this is not the only use of that start type that we have assigned above. We can also specify what percentage we want each of the rows to use. For this demonstration, I'm going to indicate that I want to specify a height for the second row definition. I'm going to place the star symbol once again. And what I usually do is specify a value between 0 and 1 to specify the percentage between each of the row definitions. For example, if we wanted the first row to be 40% height and the second row to be 60% height, I would specify .4 star for the first row definition and .6* for the second row definition. With this change, look how the second button is using 60% of the available amount of space. I can continue to make some modifications for further testing. For example, if we wanted the first row to use only 20% and the second row 80%, we see how the space available for the button is less than we had previously specified. This is a very simple and very convenient way to specify how much space you want each of the rows to use. And another great advantage of this is that since we are using percentages, it will not matter the type of device we use, since each of the rows and columns will be distributed evenly. Exactly what we have seen with this row definition section, we can apply with the column definition section. Finally, there is a simplified way to perform this definition that we have indicated in this section that we see here. To demonstrate it, I'm going to comment this code. The way to do it is inside the grid tag, specifying each of the properties. For example, if we want to define a set of rows, we have to specify the row definition property, and inside place each one of the values, in this case of height. For example, if we wanted to replicate what we did at the bottom, we would have to indicate 2* followed by a comma, .8*, and in this way we would be doing exactly what we did in this section that I am highlighting. We can do this same thing for the columns. Suppose we want to define a first column that has 10 units of space and a second column with the remaining space available. In this way, we would already be replicating the row and column layout that we had done before. We see that this is a much more simplified way to carry out the definition of rows and columns, but both are valid, and it will be up to you to select which is the best way for you to work. Let's now examine the type of layout called AbsoluteLayout. This layout is used to position and size the controls using explicit values. The position is specified by the upper left corner of each control relative to the upper left corner of the AbsoluteLayout in device-independent units. This layout also implements a proportional positioning and sizing function. Let's see it in action. And for this, I created a new project called AbsoluteLayout Demo and created a page called AbsoluteLayout Page. For this example, to be better appreciated, I am going to change the background color of this content page, and we're going to use, for example, a dark red color. Next, we're going to remove this stack layout, and instead, we're going to use the type AbsoluteLayout. Let's proceed to create a couple of buttons. Let's change the main page from app.xaml.cs. Let's launch the application to see what this layout looks like. Once the application has been launched, we can see the background of the content page, and we have these controls located at the top left of the AbsoluteLayout container. We see that the elements are positioned one on top of the other. And this is the default behavior of this layout. If you do not specify where you want to talk the controls, they will be positioned at the top left. Let's go back to Visual Studio and let's make some modifications to see how this layout works in a better way. The controls that belong to an AbsoluteLayout are going to have a couple of properties that we're going to be able to access through AbsoluteLayout, and they are called layout bounds and layout flags. Let's first examine this property called layout bounds, and we're going to apply this property to this first button that has the text click me. What you have to know when working with this property is that you must specify an X value, a Y value, a width and a height to indicate where an element, in our case the button, is going to be placed specifically. We can use some values, as for example we want to place the control in the X position 0 and the Y position at value 300. For the width we indicate a value 250, and for the height value we specify a value 100. We are specifying only absolute values, and with this change that we have applied, we already see the preview of the first button and the second button that we have modified. Look how this button that has the text click me has taken precisely the values that we have indicated previously. This is how this layout behaves in case you want to work with absolute values, but we can also work with percentages. How can we activate these percentages? Well, we have to access the second property called layout flags. As part of the different values that we can assign to this property, we have different values that end with the text proportional, which means that we can work with percentages to place the element and to assign a height and a width to the control relative to its parent container. Then we can specify, for example, a height proportional value with which we will indicate that we need the height of the button to be proportional. If you remember, we had indicated that the first value was the X value, the Y value, the width value, and the height value. Therefore, the value that we're going to be able to modify proportionally is only the height. We must specify a value from 0 to 1 to indicate what percentage we want to assign to this height value. And in this case, we will specify that we want 50% for the height. Save the changes, and look how the height of this control has increased. In fact, if we look closely, the height corresponds to 50% of the total screen. That is to say, we have a height that is going to take as a base the total height of the container, which in this case is the absolute layout, and it's going to obtain that 50% to place the height of the button. If we wanted, for example, to have a proportional width and height, we should change this value to size proportional. With this change, we must modify the penultimate value. Let's indicate that we also want a 50% for this button. With this change, the width of the control has been modified, and we are using 50% of the total value of the absolute layout. If, on the other hand, we wanted the width to use the entire width of the absolute layout, we could modify this value to a value of 1. We save the changes, and this time the button is using the full width of the absolute layout. Just as we are working with proportional values for the size, we can also work with proportional values for the positioning of an element. For example, if we wanted to affect the position of the control proportionally, we should use one of the values we see here, for example, X proportional, Y proportional, or position proportional. But what would happen if we wanted to, for example, use the proportional size and in addition to that use, for example, X proportional? Well, we would do it by first selecting size proportional, placing a comma, and then the second value we would like to use, for example, X proportional. In this way, we would already be affecting 3 values, but the horizontal and vertical sizes and also the X position. We will then modify this value so that instead of 0, it is equal to 0.5. That is, it will be located exactly at 50% of our screen in its X value. I'm also going to modify this value 1 to a 0.5 value that affects the width value. I'm going to save the changes to make this look better, and in the emulator, notice how the button is being positioned right in the center of the screen. Finally, if we wanted all the values to be proportional, we should use the value called all to be able to use only proportional values. In this case, I'm going to assign a value 0.5 for each one of the values, and if we return to the emulator, we see how the button is exactly centered using 50% for both the width and the height, taking as a base the values of the main container that is the absolute layout. Let's now analyze the next layout called FlexLayout. This is a layout that can arrange controls horizontally and vertically in a stack, and can also grab its children if there are too many to fit in a single row or column. In addition, this layout can control orientation and alignment and adapt to different screen sizes. Let's see it in action. And for this, I have created a new project called FlexLayout Demo, and I have created this content page called FlexLayout page. I'm going to proceed to indicate that this is going to be the initial page. And once I've done that, I go back to the XAML code and we're going to proceed to remove this StackLayout element. and instead use a layout called FlexLayout as we did before. To see what the default behavior of this layout is, let's create a couple of buttons. Once I have created this pair of buttons, let's proceed to launch the application. Here we see the application running using FlexLayout, and we can see how the elements are stacked as if it were a StackLayout, but we are using a FlexLayout that allows us to use some properties that a StackLayout does not contain. Let's see what they are. We go back to the XAML file, and as part of the FlexLayout we have a property called direction, to which we can assign different values. For example, we can assign a value equal to column. With this, the elements are aligned as if they were a single column. That is, the elements are stacked in this way that we are seeing in the emulator. We have some additional values. For example, we can use column reverse, whose value returns to establish a column format, but this time the elements are stacked from the bottom to the top. The default value for the FlexLayout, as we saw earlier, is the row value. But we could also use row reverse, that aligns the elements in a row format, but this time aligning the elements from the right to the left. We're going to leave the value by default, and we're going to see another property that we can use that is called aligned items. This property is going to serve us to be able to modify how the different elements that are part of the FlexLayout are going to be distributed. We can use a value, for example, called stretch, which is the default behavior. We could also use a value equal to center, which positions the elements in the center of the FlexLayout. We could also use the value start and the value end. Let's see how this start value looks like. And this is how the elements look like when we use precisely this value. Let's look at a slightly more complex example. I'm going to change the code for one that I have created previously, which is this one that we see here. The layout that gives us this pasted code is what we are seeing on the screen, which is very similar to if we had a layout in HTML format. We have a header, we have a content section, a footer, and two different sidebars. Let's examine the source code so that you understand how this example is working. First, a FlexLayout element is defined. We are setting an address equal to column, that is, the content will be in a column. Next, we specify a label element. We assign a text, a font size, a background color, and a location for the text. This displays this section that we see at the top that has the text that says header. Then we specify a section that has this comment that says body. I'm going to proceed to remove it so that you can see how this second control behaves. This control that we see here represents the footer and is a label with different properties, which is very similar to the header section. If we save the changes, we see this layout, which is very similar to what we have seen in the first example, when we had created the pairs of buttons. The elements are simply being stacked. I'm going to go back to the code that we had previously. That is to say, I am returning this code that represents the part of the body. And as part of that section, we are creating another FlexLayout element, and we're using a property called grow, which has a value equal to 1. This grow property serves to indicate that we want to use all the available space between two elements, that is to say, between this element called header and this element called footer. If, for example, we wanted to remove this property grow equal to 1 and save the changes, see how the preview gives us a behavior similar to the one we had previously, because we are not indicating how much space we want the FlexLayout to occupy. Next, as part of this FlexLayout, we have this label element, and again we are using this FlexLayout property called grow equal to 1. That is, we want to use all the space that is available to place this label element. And before we see what this looks like, let's again indicate that we want to use the property called grow equals 1. and the FlexLayout.grow assignment for the label element is indicating that we want to use all the available space. Next, we have some navigation elements, and we see a couple of additional properties. A FlexLayout.basis property equal to 50, and the second property called FlexLayout.order equal to -1. This first value allows us to indicate that we want a fixed number of units to be used. That is, we want this box view to have a specific width based on this property. If we were to change the value for a different value, for example 150, we see how effectively this first box view is bigger because we have modified this property. On the other hand, this property called order is going to allow us to decide which is the order inside the Flex layout, and we can see it in a visual way. If we examine the content from top to bottom, we could think that this part of the content should be positioned first, then this pair of sidebars should be displayed, but in reality, when we saw the code execution, we see that a box view is placed first, then the label element, and finally the second box view. In fact, we can test it by removing this property, saving the changes, and as we have removed precisely the assignment of this value, in this first place appears this label element that has the text content. Then we have this pair of sidebars, which contain the values that we have previously specified. Let's return this value as it was, that is to say, let's indicate that we want the box view to have an order -1, since we want to position it as far to the left as we can. And then we're going to place this label element and finally this box view element, which we could also modify in case we need to change its location using FlexLayout.order and assigning a different value.